Look. Okay, I've seen some students solve this problem in using a method that is correct. Like there's nothing wrong with it. But it is a method that they won't use on a multiple choice test. And so you end up thinking you've done something wrong. This is 4t plus 7 to the first power. Listen close. So this is ax plus b to the first power. So if you use the ax plus b rule that you've memorized, you do get the correct answer. But it will not look like a multiple choice answer. Because the way they did it instead was, when this is 1, they just split it apart. Because it's just two things added. Are we good to hear? If it's to the 2, you can't split it because it's being squared. So they're not being added, they're being added then squared. So you can't split that. You have to use the ax plus b rule. But here, just split it apart. Okay, the 4 comes out. This is t to the first, so this becomes t squared over 2. So does anyone have any questions here? Just looking for him. We'll get there in a second. You're good. No worries. Perfect question. 2 points for Connor. So whole room, I'm going to pay everybody for this one. Look. Look up. Come on. Okay, look up. Thank you, Kenneth. 2 points for Kenneth. Okay, look. Look. Think about what we're doing. We are finding the antiderivative of 7. I want everyone to answer this. All right, raise a hand. That means there was some function. We took the derivative and ended up with 7. We're trying to find out where did we start. So raise your hand if you know where we started. If you had a function, you found the derivative and the result is 7. So you're saying to yourself, okay, 7 is the derivative of what? It's the what that we need to know. 7 is the derivative of blank. 7 is the derivative of blank. Who knows what goes in the blank? Just gave it away, but whatever. So what goes in the blank, Dustin? How many knew that it was 7t? The derivative of 7t is 7. So the antiderivative of 7 is 7t. How many knew it before we said it? Show me hands. 2 points. You want me to talk through it again? Way back. Okay, cool. Okay. The other one I wanted to do quick is 30. So Brenda will read that to me here in a second. That was 30. Oh, 32, I'm sorry. So read 32, Brenda. Thank you. Okay, please remember on the AP test, there is no requirement for how much you have to write when solving an antiderivative problem. So I'm writing a lot. You can write much less if you'd like. Question? Please.
So that makes sense to me now, but I was just wondering, why does using the x to the n rule not work?
On which part?
On number 8. On like the number 8.
This one here?
Yeah.
It actually does. I can think of that as this. Because x to the 0 power is 1. So this is just 8 times 1, which is 8. So now if I use the rule, 8 is a constant, and I have x to the n, correct? So using the x to the n rule, this would become x to the 0 plus 1 divided by 0 plus 1, which is just 8x. So it works. Is that your question? Good.
I had a question on 12 and 24. Like when it's the 1 over x or the 1 over u, do you just not do
using the like absolute value bars is different one over here.
Oh, I know what you're talking about. Your question is actually different than what you're thinking, but that's okay. What you're noticing is this. Hold on, Allison. Really good question. 2 points for Allison. Allison, please just read to me the answer on the back of the sheet for number 24.
3ln parentheses e to the 3x plus 3 equals c.
Okay, everybody, don't miss this. Hey, look up. Okay, if you were solving the problem the way we talked about in class, I'm guessing that you would have gotten this as your answer with the absolute value bars. Is that correct?
Yeah.
Perfect. Okay, the reason on the back of the sheet that they changed it to this is because you've all memorized, in fact, let's give everyone 2 points who remembers this. What special characteristic, property, what idea are you supposed to have memorized with regard to e to some power? Raise your hand if you know what I'm talking about. When you see e to a power, you should remember something. We used it on the Unit 3 test. You're going to need it on the next test. When you see e to a power, what are you supposed to be remembering, Brianne? How many knew that? 2 points. So, Allison, because this is always positive, and adding 3 would still always be positive, the absolute value bars aren't wrong to be there, but they're unnecessary.
Okay.
So on the answer sheet, they just took them off.
Okay.
So it had nothing to do with use substitution. Is that your question?
Yeah.
The other one you're asking about, I believe, is similar.
Yeah, it's the same thing.
Okay. Anybody else? Awesome. Okay, I'm passing out a packet. Listen close. There are 65 problems in the packet. The homework is not 65 problems, okay? I'm just using this packet for several homework assignments. So we're going to talk about some of them, and then I'll assign some of them, but you don't need to panic, okay? No panic. Melting on the floor, crying. Good lotion. It's effective.
Sorry. Thank you.
Look out. No one talk. Okay, no one talk. Look out. Okay, remember, you don't do the homework here. If I see you doing the homework here, I'm going to take away your ticket. Okay? Don't do the homework here. Exactly. So don't be insane and try and do the homework here. So you take your notebook, you go straight down the page, equal, equal, equal. It's old-fashioned math. You all love the old-fashioned math. Straight down the page. Okay. We're going to look at problem 1 to start. So in your notebook, write down problem number 1. In your notebook, write down problem number 1. Okay, in your notebook, write down number 1. Then you're going to write this. Write this down. this is simply the fundamental theorem of calculus for which you were quizzed multiple times in the past few weeks. I needed to know this for the last test. Okay, this isn't new, fundamental theorem. If you have a question coming to mind at this point. Awesome. So get that written down. Just watching your pencils, see you got it. Okay, I'll pay 2 points for everyone who can answer this question. What's another symbol for V of t? Okay, simple symbol. What's another symbol that means exactly the same thing as V of t? Okay, everyone who knows this one. Another symbol, Connor, is? How many knew that it was x prime? 2 points. So I can write that. So write that one down. Write that one down. And now we're going to give some people some points for simply being able to repeat what I am about to say. X prime is the derivative of x. Fair? X prime is the derivative of x. Therefore, x is the antiderivative of x prime. So someone who'd like to say that back, I'll pay you 3 points.
X prime is the derivative of x, so therefore x is the antiderivative of x prime.
Perfect, 3 points. Anybody else want 3 points? Fair.
X prime is the derivative of x, so x is the antiderivative of x.
Perfect, 3 points.
X prime is the derivative of x, so x is the
Last one, 3 points. Well done. Okay. Look up. Come on, look up. So, Ethan, look up. You're good. Keep helping like that. Okay, so far in this class, whenever we've seen an integral, we've solved the integral one of 2 ways. We've either just taken out our calculator and typed it in. Like right here, you could just type that in your calculator and you get the result. Okay. Or in some cases, they've said, hey, do a Riemann sum approximation. And we've done that. Okay? Today we learn a third method of finding the value of an integral. And you always knew it, you just didn't think about it. This is the third method. So a way to find this integral is to find the antiderivative of this, because you all just said the antiderivative is x, and then plug in these 2 numbers and subtract them. That's another way of finding this integral. When you need to say that again, just wait up. So I'll talk back and forth, it will help. So how is x prime related to x? Say it again. Very good. So what we're saying is if you're integrating x prime, so say it the other way around.
X is the antiderivative of x prime.
Very good. So this equation is telling you that if you need to find the integral of this derivative, you can do it by finding this antiderivative first, which would be the formula x, and then just plug in the 2 numbers. That's what this is telling you.
So then would you just, the 8 minus 0, it would just equal 8?
No, because it's x of 8 minus x of 0. So we've got to find the formula for x
Oh,
first.
I see.
You good?
Yeah.
2 points. You done?
So then would you multiply, once you found the antiderivative of x prime, would you just multiply the x times the 8?
Oh, gotcha. It's not multiplication, it's plugging it in.
Oh.
No worries. Does that make sense?
Yeah, yeah, yeah.
Because it's a function. So you're going to find what the formula is for x, and then you're going to plug in the 8 and plug in the 0. Does that make sense? 2 points. You else want to see it again? Just wait. Let's write it another way. So write this on your paper. Write that down. All I did is I put f in place of x to make it more general, otherwise it's exactly the same thing. Question, Kenneth?
Yeah, I am having a hard time grasping the concept. So you said x is the derivative of dt, or
So-
dt is the derivative of
You're okay. V of t is velocity,
right.
and velocity is the rate at which the position is changing.
That's the derivative of the position.
Position, perfect. So v and x prime are the same thing.
Yes.
So are you good from here to here? Awesome. Okay, writing it this way implies something else we haven't talked about before, which is, I want to find the value of this integral. Let me write it.
You're finding the value of the velocity.
Yes.
Zero and eight.
No. Back up. Hold on. I need to write something down. Hold on.
I was right for a minute there.
You're just fine. Look. This, I think, will help. Okay. So what we had written down was this. I think it will help if I, just give me a second. Okay, are you okay with that?
Yes.
Good. Okay, so what we're representing is, what if we really did have a formula for the velocity? What if the formula for the velocity turned out to be, I'm going to do something really simple. It just was, let's just say 3t squared. Okay? That means x prime is really 3t squared. Okay? What this is telling you is, if you're trying to find the integral of this, one way to do it would be to type into your calculator this. 0 to 8, 3t squared dt. Understand? Awesome. But the fundamental theorem shows us another way we can find the value of the integral. We can find the formula for x. This is the formula for x prime. So you say it back to me. How is x and x prime related?
X is the antiderivative of x prime.
Right. So what I do here is I go find x.
Then you plug it in, and then, okay.
So I'm going to find x, okay? Just stay with me, you're doing great. Then I'm going to plug into x, 0 and 8. Okay, everyone needs to write this on your paper, I promise. You need to have this in your notes. The question was spot on, it's perfect. Okay, this is new notation. You need to start using it. This bar does not mean the same thing as this. Okay?
Okay, so one's curved and one's not.
Yes, so this one's curved. Yeah, that was a little poorly written. This one is straight, vertical line. This one means integral. This means what Ken and I just talked about. So we have a formula here for x prime. The fundamental theorem says, hey, go find the antiderivative of this formula. The antiderivative would be called x of t. And then once you have that formula, the bar means put an 8 into the formula and put a 0 into the formula and subtract them. So the bar means exactly the same thing that we wrote here. It's just a compact way of writing the same thing. Like that. Yeah, this is very handy. You need to use this. These are the same thing. Question. Kenneth? Better? Okay. Anybody else? Awesome. So that's the biggest idea for today, is that we can find the value of an integral now without a calculator. Because we can find the antiderivative of this. Once we have found the antiderivative, we simply need to plug into that antiderivative the limits and subtract them. The result will be exactly the same as you get on your calculator. In fact, the calculator is still an estimate. This isn't an estimate. This is a perfect computation of the integral. Question?
Oh, no, sorry.
You guys always looking around for me. Okay, cool. All right. So now we're going to practice that idea. So, you look right here. Not helpful. Okay, look. Here's problem number 1. Okay, come on. So here's number 1, right? It's an integral, but you have to do it without your calculator. So you remember, I need to find the antiderivative of this, and then I need to plug in the limits. So your brain stops thinking about integral temporarily. You just think antiderivative. So ignore the 8 and the 0 for a moment. We need to find this antiderivative. A huge hint. I cannot recall any problems where I really want the square root on the bottom. If we run into one, I apologize for not remembering it, but I just don't think I've seen any. So I'd like to get that square root out of the denominator, which is really easy. It really just means 1 plus x to the 1/2 power. Now it can move. No worries, like that. Question?
I don't remember what that.
Oh,
You go
okay.
back and forth and split it out.
Yeah, listen to question. We good? Cool. Okay, now we have, look, hey, come on, focus. We have the ax plus b rule in front of us. There's an a right here, it's 1. Make this a little bigger so it kind of work. Okay, so right here, this is 1. That's the a in the ax plus b rule. So it's 1x, that's ax plus b. Addition order doesn't matter, so any questions about what you're looking at? So it's ax plus b to the n, no worries. So it's ax plus b to the n. So I use the ax plus b rule. Right there. 1 over a. There's the a. There's the a again. Plus b, n plus 1, n plus 1. And because I'm doing an integral, I can't forget the limits. So now I evaluate it 8 to 0. Question? We need to just say it again or say it differently. You're good.
And then,
Ready?
would you not put plus?
Outstanding question. 3 points for that one. We gotta go to the board, so in fact, just wait a second. I'll show you in a second. Don't let me forget though. So don't worry about the plus C. I'll show you why in a moment. It's a little hard to show at this juncture. So, are we good? Cool. Oh, please, go.
Do we not need to simplify that, or can we?
We're going to. I just want to make sure that makes sense. So now I would do this. Come over this way. Okay, so right here, negative 1/2 plus 1 is just 1/2. So this is really x plus 1 to the 1/2 power, which is the same thing as the square root of x plus 1. The denominator is 1/2 as well. So does anybody have a question to here? Please.
Why don't you change it back to that?
Oh, gotcha. Perfect. 3 points. This case, I'd say you could leave it either way. I changed it to 1/2 power because my rule says something to the end.
Yeah.
I changed it back to root just because I'm more comfortable with root, but you can leave it 1/2 power. Anybody else? Cool. Okay, dividing by 1/2 is the same as multiplying by 2. Any questions to there? Dividing by 1/2 is the same as multiplying by 2. So the math is, you've got like 4 divided by 1/2. It's 4 multiplied by the reciprocal of the 1/2. So it's the same as multiplying by 2. Is that what you meant, Aaron? Yeah. Cool. 2 points for Aaron. Anyone else? Okay, look here. Okay, now we have to plug in the 8, we have to plug in the 0. So, there it is. Write it down. Please.
That 8, I don't know how to describe that, the 8 with the line for the 0. Does that interfere with any of the rules?
No. It's something that occurs after the rule.
Oh, okay.
So we're finding the antiderivative of this. Once we've found the antiderivative, the fundamental theorem says we now need to plug in the 8 and the 0.
Yeah.
So it has nothing to do with it.
Then for the excellent one, did you use a rule or did you just simplify it? Did you just break it down?
From here to here?
No, from there to the next.
From this one to this one, from this one to this one. I applied this. So this means take whatever's written here and put in 8 for x. So I did. Subtract, same formula, plug in 0 for x. There we go. More for David. The value of the integral is 4. If you check it on your calculator, you'll get exactly the same answer. Please, Hunter.
Just like, why would you change square root of 1 plus x to 1 plus x?
Gotcha. So the rule is this. It's just memorize these facts. Square root means 1/2 power. Cube root means 1/3 power. The general rule, I believe, looks like this. Like you have an A here and a B here. But the 8th root, or the A root of x to the b power is the same thing as x to the b power divided by a. So if you have Mr. Rucky as a teacher, he likes to yell very loudly, the power is on high and the roots are below, and then he has you say amen, and then he says it again. Power is on high and the roots are below, and then he says, give me an amen, and you all say amen.
Like, do we do it?
I'm no good at
Do we
it.
listen to it? Well, we have Peyton stand up and do it?
No, that's
He's like, power is on high and the root is below. No, come on, you gotta be in sync. He says the power is on high and the root is below.
Then we all say
Yeah, no, not yet.
It's a virtue.
It's like the power is on high and the root is below. Now give me an amen. He's on his crap sitting there.
Oh, you can come in here then.
He could come in. He's
Yeah,
not
we should
there.
go get him.
If he was there, he would have yelled
We gotta
back.
learn. Oh.
Who yelled back? We should just talk to Rucky sometime.
I did tell my class yesterday that despite
I know how to do it.
despite my best, it hurts your voice to do that. See, I don't like to do that. Yes. I've tried my best to learn from Mr. Recti to be as enthusiastic about every little minute detail of math. I can't seem to conjure up the enthusiasm. But in my defense, I feel like I have a badge of honor that has surpassed every teacher on the planet. I'm serious. Like I feel like I can say with pride that no one has shown more enthusiasm for a subject than I have. Like I have X-ray proof. And I've never heard anybody else stepping into the board and breaking their hand, just because they got so excited. So. Mostly I'm kind of trying to be calm and everything, I have the evidence. So.
It's funny because he's like, evidence.
Oh, it's right there. I can't even open my hand anymore.
Yeah, because your actions speak louder than words, even louder than Rusty.
There you go. But I'm still working on that enthusiasm. He's very good at this. All right. Any other questions here? Anyway, okay. I'm going to show you a different one. Look, I'm going to have you work it. I'm going to walk the room. You stop me if you feel like you're getting stuck. It's not exactly the same, but it's quite similar. Yeah, I hate talking like that. You can't talk the rest of the day. So you're going to, in your notebook, work problem number. 1 second. So in your notebook, you're going to work problem number, 2 squared to 9 is 3. 14, go. In your notebook, work problem 14, go. In your notebook, work problem 14. Did my best. I'm not frightening by nature, but I can conjure up a pretty.
Hang on, so we don't gotta switch
That's right.
Okay, how do we know which one? Like, so we were just like talking about like this is on
One class I took,
so when it has limits, that's when we know the bar. Oh, yeah. I wasn't seeing the difference if there was wiggles
show me the so that's it. Three has power. Powers are high and third power stored. Or it's something yelling at it.
Wait, why do we not worry about the C?
Yes, I did forget. See what I mean? So don't worry about it yet. You know.
We just did this. Here, I was like, oh no, I think we're gonna do that.
Okay, so I'm talking to somebody, you got to here. Look. So you got to here. Moving on. You lost Brianne as well.
We're good now.
Okay. So look, hey, right here, don't let this stop you. It's time to plug in the 3 and the 0. You need help getting to here. So I have this. This is just like the one we did earlier today. It's A, the A is 1, AX plus B to a number. So the rule says the antiderivative of this is going to be 1 over A, the AX plus B to the number plus 1 divided by number plus 1. And we need help getting here. So, what's that?
I'm still confused how you got 3.
3. So, I'll talk back and forth with you, then you'll see it. What's 1/2 added to 1? 1 1/2. But that's the same thing as 3 halves.
Oh.
No worries. You with me?
Yeah.
Okay. So that's where the 3 comes from. So it's 3 halves, and then dividing by 3 halves, remember, multiplied by the reciprocal, same thing as multiplying by 2/3. Good. Keep asking. Hey, no, don't hesitate to ask. You have to see it. If you don't see it, it doesn't help you. You got to be able to see it. So stop. No, watch. Okay, everybody look here. Everybody look here. Okay, everybody just got to get memorized a little more firmly that multiplication and division, kind of interchangeable operations. So what we have here is this. You've got x plus 1 to the 3/2 power. It's being divided by 3 over 2. Okay, all you're going to do is multiply by the reciprocal. That means you've got 2 over 3 multiplied by x plus 1 to the 3/2. You can write it like this if you like, or you can say top times top, bottom times bottom, and write it like this. There's no difference. Get comfortable with those being the same. They're the same thing. Questions here? Okay, we good here? Everybody else? Okay, so now it's time to plug in the limits. So we're doing that here. Okay, this is why Mr. Rucky says the power is on high and the roots are below. You get to choose. Yeah, thank you. You get to choose. You can do the root first or the power first. Honestly, if you can do the root first, that's best because the numbers stay smaller. Start doing the power first, you get large numbers, harder to deal with. I do think there are some cases, though, where you have to do the power first. So here, 4, square root of 4 is 2. 2 cubed is 8. 1 square root is 1. 1 cubed is 1 times 2/3 is 2/3. So anybody need to do this again? Oh yeah, but that's human nature. It's always easier to be talking with somebody. So that's why we talk together and you work to do yourself. I'm the same as you. It's always easier. Please, don't talk. I can't hear it. So right here we got 4. So I got to talk with you so you can see it. So we got 4, right? So you got to do either 4 cubed first or square root of 4 first. Which one do you want? Good. And what's the square root of 4? So the result 2 now has to be cubed. So 2 times 2 times 2. Is that your question?
Yeah.
Good. 2 points. Please.
So you won't be able to just do this in your calculator. You can't have to do
You cannot.
You have to
This
do
is
it
all
every
on.
time.
Yeah, this is all on the non-calculator side.
Nice. But you can plug it into the right?
No, this is all on the non. Well, yeah, homework, yeah. But to help you get through the homework, but you do have to. Yeah, you got. Yeah, you. That's fine. It doesn't bother me. But you do have to migrate to the point where you are not. Hey, everybody, listen. 2 for Brenna and Peyton. Using your calculator to help you get through the homework is a smart idea. But an even smarter idea is getting away from the calculator as soon as possible, so that when you are really taking the AP test, you're not having this terrible feeling like, oh, I should have practiced this more. So, yeah. Other question? Good work. That's it. This is the value of the integral. Sugana?
I don't know if you explain where the plus D goes.
Oh, gotcha. Thank you. So, right here. Okay, everybody, look. Come on. Eyes up.
Sorry.
Very good. Okay, look. Right here, when we found the antiderivative, there would be a plus c. Like, focus on the board. There would be a plus c right here, correct?
Yeah.
Okay. Yes? Plus c?
Yeah.
Yeah, you went like this. So there's plus c here. Look, that means right here there'd be a plus c. But then it's minus everything. So there'd be a parenthesis here, plus c, plus c. The negative must distribute. So this c and this c subtract to make 0. So when you're doing an integral, we don't worry about plus c, because it's going to disappear anyway. Okay, next one. So now we'd like you to turn to number 9. So do do number 9. 9 involves a U substitution, otherwise it is the same type of problem. Go. Stop me if you need help. Number 9, please. Stop me if you need help. Yeah, there's a U substitution required in number 9. Outside of that, it is really very similar to what we've been doing. So. On May 16th, we're going to find out who's been putting gum under the tables and watch them and laugh as they clean the gum off the tables. I would.
Find out.
Oh, I have ways, so. What's that? Because the test is on May 15th. We're not taking any time away from the test. May 15th is the test. So on May 16th, we're going to turn all the tables over and feed it out to whoever put them on the phone.
But you've been paying attention.
I've been taking pictures, you just didn't know. Hit the cameras.
I've been a long time. Video it yourself.
Hey, remember the big idea here. You're finding an integral, right? You're finding the integral without your calculator. Step number 1 is find the antiderivative. So temporarily, you just forget about the limits. Temporarily. You just focus on, I need to find the antiderivative, and in this case, a U substitution is required. Does that make sense? Good question. Again, I would move the root to the numerator like I showed you before. 1 second. Okay, your goal is to get to step 6. Your goal is to get to step 6. Then I want you to stop there. If you get to step 6, just stop there for a minute. So stop at step 6. Yeah, sure. Absolutely. I'm going to show you a different thing in the second page. The way you're going is fine. So go to step 6 at least. If you got further, that's fine. But I need to show you something new at step 6. Yeah, same thing. Negative, think about it. -1 over 2 is the same thing as it's the same. Yeah, no, good question. So what you're doing is big step is find the antiderivative, have the antiderivative, plug in. Now I have a very simple find the antiderivative.
Did you get negative 1 with the 1 minus x squared all squared?
So, okay, the process is called use substitution because I have to substitute stuff. Now it's math. You can't just say, oh, this sounds fine, I'll just substitute. It's got to be equal. So this is where your use of the equal sign becomes critical. Why I'm always ragging on people and saying, you don't use an equal sign in math, you're not doing math. You might as well just go do positive or something, okay? It's not math. Math is about equality. Right here, u is the same as 1 minus x squared. So in place of 1 minus x squared, it is totally legal to remove that piece and put it in.
I don't get how it's legal to like pull out the 2 and pull out the x. Just next.
Hold on, when you said pull out the 2 where?
Like I get how you can pull out the 2 as
Which number are you looking at?
number 1.
Okay, keep talking.
So like I get how you can pull out the 2 becomes x. But like I just don't get how then you can basically put that to the left and then put the x to the right.
Oh, let me say it back to you then. You're okay. Let me say it back to you. Are you okay that this on the bottom is really 1 minus x squared all in 1/2? So we can move to the numerator and you get something like this. You write it down below. Just get rid of it. So you'd have integral 0 to 1/2 2x multiplied by 1 minus x squared all to the negative 1/2 power. Okay, stay right there, you're good there, right? Okay, when you look at this, you should see 3 things being multiplied. Do you see 3 things being multiplied? What are they? So there's the stuff here to the 1/2, that's one thing. Perfect. So 3 things multiplied means they are 3 factors. Therefore, the rules of derivatives and antiderivatives allow you to remove any constant factor. So that's where the 2 can come out front. Are you okay with that?
Yeah.
And you have this. Okay, now answer. You're doing great. Just answer this question for me. What is 5 multiplied by 2? What is it? What's 2 multiplied by 5? Say it. Okay, so the order of multiplication is irrelevant, which means I can switch this and this because they're just 2 things multiplied. That's what I did here. So does that answer your question?
So the keys are on your eye.
2 points for Kate. Okay, please raise your hand if you successfully got here to number 6. Show me your hands. Come on. Who got to here? Show me your hands. Who got to number 6 successfully? So you should have on your paper 2 multiplied by integral 0 to 1/2 of u to the negative 1/2 du over negative 2. Who has this written on? Just look at your paper. It's either there or it isn't. Who has this written on their paper? 2 points. Questions to getting to here?
Do you have to keep the 0 and then 1/2 there? Can you take it out while you're doing it?
No, you should keep it. Hey, watch. Come on. Over here. Come on, look up. Okay, new step here. New step. It's a really easy step. It's easy to understand. It's easy to remember. Don't do that. Watch. Okay, we're doing a u substitution so we can find the antiderivative. But we're doing it with an integral. There are limits. The limits are values of x. See how I labeled them? Okay? We want to change them to be values of u. And it's really easy because we have a formula for how to switch between x and u. So look at my notes right here. I just plug it in. If the x value is 1/2, then 1 minus 1/2 squared will be the equivalent value for u. So So write this in your notes, right here, number 7, write it down. Write down number 7, please. Here's the formula. It relates x and u. It's all about using the equal sign. Any questions coming to mind? Please, Suzanne.
So where did you get the x from? Like, where's the x equals 1/2 from?
So when you started the problem, this 0 and this 1/2, they're values of x.
Okay.
And so I'm simply taking those x values and converting them to appropriate u values. So now those are no longer values of x, they're values of the letter u. For Suganda, anybody else? Please.
Just writing it down instead of like putting, sorry, do you want all of our new stuff on the right now? That
Oh, I got you. You're a genius. Hold on. Take it for Nate. Good observation. Here's what Nate noticed. No, I gave him a ticket because I really appreciate that you listened very carefully to what I said last time. I figured out in V6 yesterday something that should have been obvious 8 years ago. It just wasn't. So for 8 years I've been doing it a certain way, and then yesterday it just kind of occurred to me that, like, wait a minute, it's better to do it the other way, to like work the problem straight down the page, like I always ask you to do, and then do this up over on the right, because it's kind of the scratch work that supports this. So I do think this is a better method. So I apologize for showing you the opposite yesterday, but I kind of feel like, well, there's no sense to continue down that path, that this way is better. So that's why I switched it. Does that make sense? Yeah. Good call. Anybody else? Sweet. Okay, right here. So any questions to 9? Please.
I don't know if you answered this earlier, but how come it went from 0 to 1/2 to 1 to 2?
Gotcha. So when we start the problem, this is x equals 0 and this is x equals 1/2. But we're changing the entire problem from x to u. So we've got to also change these.
Okay.
And here's our formula for how they change.
Yeah.
And so I used the formula here in step 7 and figured out that if I have an x value that's 1/2, well, 1 minus 1/2 squared is really 3/4.
Okay.
So I get new limits. Now make sure, hey, make sure you put the limits in exactly the same spots. Don't be swapping these just because one is now bigger on the bottom. It's a substitution using the equal sign. Super tested.
What's the reason for the substitution formula?
Gotcha. So you actually can solve the problem without changing the limits. But there are some problems in the future that if you don't do it this way, you will miss those questions. So my preference is I'll teach you one method that works for 2 different problems instead of teaching you 2 different methods for 2 different problems. Other question? Awesome. Okay, right here, we just need to find the antiderivative. So this is just u to a number. So the rule is add 1, divide by the same. But we still got to plug in the limits. Okay? So who has number 10 written on their paper? Show me. So get number 10 written down. Go. Get number 10 written down, then I want you to keep going on your own. Well, we better skip one. We got to get one more problem in here. So get number 10 written down. That is a good thing. Things go by fast, that means your brain is highly engaged. If things go slow, your brain's not working, so it gets bored. It's tired. It's like, ugh. Okay, so we got this. Questions to 10. Anybody? Okay, after 10, there's no more calculus, just arithmetic. So you just start plugging stuff in. Now I did simplify it a little bit to make it easier for me. This is u to the 1/2 power. That's the same thing as square root of u. I'm dividing by 1/2, so to me it's easier to multiply by 2. Please.
You move the other parentheses.
Yes, thank you. That was just miswritten. points for David. Now I plug in the values. Anyone have a question to 12? Go ahead and catch up in your notes. Don't let me go faster. Rachel, please.
On 11, how come it's not a negative 2 times 30?
Oh, gotcha. I left the -1 here.
Okay.
So either way, right here, all you have is -1 multiplied by 2 multiplied by root u. So on the next line, I went ahead and said these two would make it -2.
So going so from 10 on the bottom, it's a negative 1 half.
Oh, gotcha.
Sorry, negative 1 half plus 1.
You can help me. What's -1/2 plus 1?
It's going to be positive 1 half.
Yeah, you see it now? Good question, 2 points. Anybody else? Please.
So, okay, why can we just, oh, never mind.
No worries.
Okay,
Every, but you're,
-1, right?
well, not really.
Oh,
Stay with me. There's no distribution.
okay.
So this is 3 things being multiplied. So there's no distribution, but they don't matter. So I can just think of that as -2. So the next line, it's just -2 root of that number minus -2 root of the other. Is that what you meant? Okay, everybody caution. You've got to be really, you have got to be diligent on your homework in this unit. There's arithmetic. If you mess up the arithmetic, you will get the answer wrong. And they don't have sympathy for you, okay? It's like, no, you're supposed to know math. This is AP calculus. This is college level calculus, okay? So be diligent in your homework and develop good habits. Like habits of, hey, I'm getting them right. I'm not like getting it wrong, checking it, fixing it, getting it wrong, checking it, fixing it, getting it wrong, checking it, fixing it. You don't want that habit. You want getting it right, confirming, getting it right, confirming, okay? I like to do production analogies. It's like, it doesn't really good to keep fixing your line every time you perform it. It's got to be right when you perform it. So, anybody else? Awesome. Any questions to hear? Okay, next one I want you to do then is number. Let me find it. Hold on. Number 3, please. Look at number 3. Oh, please. My answer's wrong. That makes sense. Number 3, hey. Just a reminder on number 3. Just a reminder on number 3. It says, what is the average value over the interval? So you first have to remember that to find the average value of a function, you must integrate the function, and then you must multiply by 1 over the width of the integral. That's what's required to find the average. It's nothing special. You're just doing what we've done before, and there's an extra 1/3 out front. So it's no big deal. Go to work. Remember, we've talked about how to do this today, so just use what we've talked about. Go. Stop me if you have a question. We can use substitution to find an antiderivative, and then we can switch the antiderivative back to x, and then use the x limit as the problem. Or we can just forget about x forevermore, switch everything to the same. All of this, my choice was, we just switch to you, and the word of it will work. Different from how it if you're doing an integral with use substitution. If you're doing an integral without use substitution, right, you're doing antiderivative.
Yeah, I was trying to do
So the big step, so it's a case that you have the big steps and then the big step. The big step is finding an integral without our calculator. So we first must identify the antiderivative. Now, on the last problem, we had finding the antiderivative. It's called substitution. And once we found the antiderivative, then it's time to plug in the limits. So that's when we call our shots on. So like right here, still got 3. So right here, that's going to be 3 cubed over the release. But now that must be evaluated from -1. Because you don't have the antiderivative around minus. Okay, couple reminders. Look, okay. So one of the one of the most valuable things about calculus is it forces your brain to learn how to manage multiple concepts simultaneously, so that you are a much more productive employee or business owner or whatever you're going to do in life. Okay, it's that simultaneous thinking that's just not required in a lot of other classes. So we've got big steps and we've got little steps. It says right here, find the average value. That's a big idea. I've implemented that big idea right here. Okay? I've got the equation set up to find the average. But now I've got to find this integral. If it were the calculator section, it would be easy. Plug it in, you're done. Okay? Because it's not. How do we find an integral without our calculator? We first find the antiderivative. So stop thinking about the limits temporarily. Focus on antiderivative. Well, we've got 2 things being added. So, just like a derivative, I would split them into 2 separate things being added. Questions to here? Okay. Now each of those has a nice rule, because it's just t to a number. So the rule says, don't lose track of stuff though. Look, the 3 can only come out of this one. It doesn't come out of this one, because 3 isn't a factor of both terms. 3 is only a factor of that term. You can only, calculus is about being precise. You can only factor out a factor. You can't pull out things that aren't factors. So now I've got here, I do the antiderivative. This becomes t to the 4th over 4. Okay? And somebody was helping, I wrote it wrong. Really good.
Yeah, I wrote it wrong.
You got it written wrong, yeah. So it's t to the 4th over 4. This antiderivative becomes t cubed over 3. Once I have found the antiderivative, now the bar shows up, because now I've got to plug in the numbers into the antiderivative. Okay. Does anybody need me to talk about anything again to this point? Okay? Now it's arithmetic. I want to show you a trick though. Okay, step number one, brute force. You just plug in the values. But right here, look at my board. Come on, look. On an integral, you are subtracting, right? But you often subtract two terms. So don't forget this parenthesis, because the negative has to distribute. Otherwise, you'll step in a trap. They will for sure have an answer where they anticipate that you forgot to distribute the negative. Okay? You may have a question here. Okay, now here's the trick. Watch. With integrals, look at the board. This term, look out, come on. This term here is always going to be very similar to this term. Look at it. Because they both came from here. So I don't usually add these first, because they often have different denominators and it makes a lot more work. I just keep going for a minute. I'm looking to add these two first and these two first. And it worked out because here, this becomes negative 1/3. Negative 1/3 plus negative 8/3 is negative 9/3. That's actually just 3. 12 minus 3 is 9. So that was a lot easier. We just finished the arithmetic. This packet, again, way too long for one assignment. You can see that problems take a bit of work. It's fairly involved. So I will be sending you a text in a few minutes that will tell you exactly what problems to work for homework. Good work.